So I asked you guys to expand 5 cubed, and you guys told me that cubed means multiplied by itself three times. So we did just that and expanded it to 5 times 5 times 5. And this one has an exponent of 3, but these have exponents of 1. So 5 times 5 times 5, 5 cubed is equivalent to 125. Example 2, we had 5 squared times 5. So 5 squared, you guys said, was equivalent to 5 times 5. And this is, of course, 5 to the first power. And we end up seeing that this looks very similar to what we had up above. You guys grouped this up and said 5 squared was equivalent to 25. And 25 times 5 is, again, 125. Even though we have two different questions, they have the exact same answers. Example 3. Let's take 5 squared times 5 squared. And here, you guys told me that that would be 5 times 5 times 5 times 5. Essentially, that would be, well, actually, taking a look here, all of these have an exponent of 1. And that's 1, 2, 3, 4, 4 of them. So that's the same as saying 5 squared. Some of you guys broke this down and said, though, that 5 squared, that's 5 to the 4th. 5 squared is 25. So 25 times 25, that is a perfect square, 625. Then we took a short moment to go over how everything should be proportioned. So we said that this blue B is going to represent our base. And this pink X is our, of course, exponent. Oh, I forgot to add in this little purple N for index. And of course, we have our red coefficient. Now, the reason I wanted to rewrite these here for you is because you have to make sure that your B is significant, or your base is significantly larger than your small exponent, and that your exponent is kind of higher up. And I saw this problem whenever you guys had your coefficients, that you guys started writing them smaller and smaller and smaller until it ended up looking like an index, or vice versa. You need to make sure that you have the correct proportions with all of your letters and numbers. Take, for example, if you wrote that 2 very large, it would look like a 52 and not 5 squared. So continuing to example number 4, we have 2 cubed times 3 squared. Now here, we went ahead and said that that would be 2 times 2 times 2. You guys even grouped it off for me. And then, I'm going to use a different color here. You guys said that we had 3 times 3. Okay, so then we would say, well, 2 times 2 times 2, that's 2 cubed. You guys all knew that that was 8. And 3 times 3 is 9, giving us a final solution of 72. Okay, let's try something similar but different. How about 2 squared times 3 cubed? Now it looks very similar, sometimes you might think that you end up with the same answer, but that wouldn't be the case. Here we have 2 times 2 times 3 times 3 times 3. And a lot of people made mistakes here. Of course, 2 times 2 is 4. And 3 times 3 would be 9. And 9 times 3 is 27. So even though it looks the same, we end up with 2 very different answers. So we moved it on to example 6. Example 6 says 2a times 2b. Now, this is the one that confused people the most, and I said let's look back at examples 1, 2, and 3. So here we have 5 to the first power, and that's equivalent to 5 cubed. But here, I also have 5 squared times 5 to the first power, and it gives me the same answer as 5 cubed. Here I have 5 squared times 5 squared. It's equivalent to 5 to the fourth power, which is the same as 5 to the first, 5 to the first, 5 to the first, 5 to the first, is also equivalent to 5 to the fourth power. Now, what you guys came up with was the fact that, well, it seems like all we were doing was adding up our exponents. So our answer here should be 2 to the power of a plus b. So let's move on to example number 7. That one says 2a squared b times a to the fourth power. Okay, so we went ahead and rewrote this by expanding. We said 2, and then a squared was a times a, and b, there was only one of them. There's technically an exponent there. Okay. And then we had again a to the fourth. Now, I didn't have to expand it. I could have used this new rule that we had made up. And I could have said 2, which is our coefficient, put that up in the front. And then here I had a to the second plus 4 power. And then, of course, I have my b, giving us a final answer of 2a to the sixth power b. Trying really hard to make sure that that 6 doesn't look like a b. So our last example, example 8, we had 3a to the fourth b times 5a squared b cubed. So let's go ahead and take a look at this one. Now here, let's see, there we go. I had 3 times a times b, just one of them, times 5 a squared, so that would be a, and then here I have b cubed, so b. Now, again, we're going to rewrite it by using our rule instead of expanding. But I'm going to rearrange this. I want both of my coefficients in the same spot. 3 times 5, and then that would be a to the, oh dear, sorry, that was fourth power. A to the fourth power plus 2, and then b to the first power plus 3. giving us a final solution